Right, so this is a problem from the classwork of October 9th, solving for x by first completing the square. Let's start with this, adding 1 to both sides. Here we go, x squared minus 7x equals 1. So notice I've left some space here. What we need to do is figure out what I've been calling the magic number. And here, what we do is to, let's see, well, let me maybe write this off to the right here, just to keep this straight. A is 1 in this problem, B is -7, and C is -1. That's, in other words, ABC when we started. What we need to do basically is find half of B, or as I prefer to say, multiply B, the -7, by 1/2, and that gives us -7 halves. Then what we do is we take that B divided by 2, or -7 halves, and square that number. So I'll write that in blue here, -7 halves squared, and let's see now, 7 squared is 49, and 2 squared is 4. Therefore, on this approach, the magic number is 49/4. So here we go. Okay. Let me kind of put a little brace here. All right, so let's take stock of where we stand right now. I'm going to rewrite this even a little bigger because we have some rather complicated looking fractions going on here. Like so. That's where we stand right now. So truth be told, when I first did this in class, these kind of problems in class, a week and a half ago, I think, what I would do is proceed along these lines. We would simply live with this fraction and say, tough luck, that's just the way it is. And the fact is, we don't have to live with these fractions. Once we've done the process so far, and here we are close to completing the square, we don't have to live with fractions. And I've frankly come to the point where I'm saying, don't live with fractions. We can clear the fractions. One of the students in the class has, as far as I can tell, is the first discoverer of doing the following at this point: clearing the fractions here. We don't need to live with the fractions anymore, and there's no real reason to do so. In other words, we're suggesting here to multiply both sides by some number that's going to clear the fractions, just like we've done practically from the first day of the whole semester. The little slight trick is, I suppose, is to really guarantee success, what we need to do is multiply both sides by 4a squared. 4a squared. In other words, go back to the original situation, look at what a was. Sorry about this adjustment. A was 1. So 4 times a squared is 4 times 1 squared, which equals 4. Now that number, 4, will actually do the trick. It's guaranteed. It's actually guaranteed. So what I'm going to do is now multiply both sides of the equation by 4. Now notice, this is before doing anything with fractions. No more adding fractions and common denominators and all of that great stuff. What we're going to do is now clear the fractions. So you have to distribute. 4 times x squared. There you go. 4 times x squared. 4 times -7, which is -28. And then 4 times 49/4. The 4's cancel. You're left with just 49. On the right side, 4 times 1 is 4. 4 times 49/4 is 49. The 4's would cancel. Now, observe, there's no more fractions. Fractions are out. I think this is a real plus. We might have some somewhat larger numbers to deal with, but they're not fractions. So now what do we do on the left side? Well, like before, but I believe a lot easier, what it comes down to is take the square root of 4x squared, 2x. The square root of 49 is 7, so the 7 goes there. We have subtraction, so subtraction goes there. On the right side, simply add 49 plus 4, 53. And as a check, recall how we checked this. multiply, I mean, 2x squared is 4x squared. Easy. 7 squared, 49. It's a middle term here that we have to really check carefully. Remember the process. 2x times negative 7 was negative 14x. Double it, you get negative 28. So everything is checking just great. Now take the square root of both sides. Square root of both sides. And remember the plus minus. This is always the danger of this approach. But there we are. And now the left side simplifies very nicely. 53 is not divisible by, I don't think anything. I think 53 is prime. It's certainly not divisible by 4, so don't worry about, oh, hello. That's a 53, not a 54. 4 was on my mind. Now we're just solving for x. So add 7 to both sides. 7 plus or minus square root of 53 equals 2x. And then finally, dividing both sides by 2, we have x equals 7 halves plus or minus square root of 53 divided by 2, and put a box around it. Okay, so this is really quite revolutionary. We have cleared the fractions after having completed the square, brought in the magic number, and we had a bunch of fractions to deal with. Clear the fractions out, and it turns out the crucial thing is multiply by 4a squared. If you remember that, then it's all a nice situation. Okay, so far this is great, and I from now on I'm going to call this kind of like the kind of basic method, or maybe old method. There is another method out there which I only discovered yesterday, called the Hindu method. If you're not interested, you can stop the video and do it. But if you're willing to learn something new, it'll be even better, even faster using the Hindu method for solving these problems. And I'll do that on the next page. So you can stop the video now if you want, but if not, we're going to try the Hindu method. So here we go. Let me please rewrite the problem from scratch here. So we're saying x squared minus 7x minus 1 equals 0. Okay, so I'm sorry. Let me get that. All right. Okay, there we go. Okay. Right. So the Hindu method. Let me just jot to the side. What is A? 1. B equals negative 7. And C equals negative 1. Step 1 is to multiply both sides by 4a. So step 1 is multiply. I'll shorthand off the right. Multiply both sides by 4a. Well, a is 1. So 4 times 1 is 4. Comes down to multiply both sides by 4. So I'll write that out right here. 4. Make sure that's not disturbing the camera. Oh, hello. X squared minus 7x minus 1 equals 0. And we can say 0 times 4 on the right, but the right side just zeroes out all the time. All right, distribute. And where do we stand? We have 4x squared minus 28x minus 4 equals 0. Let's see. Let's bring that negative 4 that's there over to the right side. So we now have 4x squared minus 28 equals 4. The second step to this process is to add. My shorthand would be plus b squared. Well, b is negative 7, so we're going to be adding 49. B squared equals 49. Add that to both sides. And I'll leaving that space here just like before. I guess you could say this is kind of a new magic number, but much easier than before. 49. Okay. Observe we didn't have to go through that funny process of take half of b and then square that number and then write it in, blah, blah, blah. You don't have to do that at all with the Hindu method. Right here, what's the square root of 4x squared? 2x. What is the square root of 49? 7. There's subtraction going on, so it'll be subtraction inside. We're squaring that. And then 49 plus 4, 53. Take the square root of both sides, solve for x. See how simple this is? This is really great. Plus or minus root 53 And then this is just like before, but it has this extra advantage that, let me see, 7 plus or minus root 53, and that's equal to 2x. It has the advantage that we don't have to go through that extra process of finding the magic number the way we did. And I believe this is the result, just like before. 7/2 plus or minus square root of root 53 over 2. Right, so this is called the Hindu method. Uh, of completing the square. And much to my surprise, I have only been able to find one YouTube video on this method, and I included that on our Canvas site. This is the way to go. This is state of the art. So I hope this was helpful. I'll continue to provide this alternative way on the future problems as well. If you're really committed to the old way of doing things, and which even so, that what we did before, we did still clear the fractions, and that's a novelty, and that's thanks to a classmate of yours to suggest this idea, which is a really helpful thing in terms of fractions. And when we do it this way, we don't have to worry about rationalizing denominators either. But the Hindu method's even more powerful because it avoids having to worry about all this stuff we have to do here of half of the b and square it. All that can be thrown out. You just don't need it anymore with the Hindu method. So I hope that's helpful, and please do let me know. Thank you.